I do. All right, so we're going to continue our work here with integrals. We're looking at integrations with that Euler's number, base e, today. So you guys remember this very convenient rule here, right? The derivative of e to the x is e to the x. So just like every other day, working backwards is pretty simple there. The integral of e to the x is e to the x. But of course you get a u and stuff, so, or a c. So go ahead and write this slide down here, and I'll pause for it. All right, so let's begin here. Number one, go ahead and write down number one. We have integral of e to the 5x minus 3. Now, we're going to be doing a lot of u sub today, and usually, but not always, when you're dealing with e functions, the u will be the exponent. Okay, not always. Matter of fact, I think number 3 is an exception. But a lot of the times, the u is the exponent. So, so for number 1, if I were to say that u is equal to 5x minus 3, du dx would be 5. Let's rewrite our integral now. So now it's going to be e to the what? U. And then dx is going to become du over 5, right? But I'm going to just put the 1/5 out here. All right. And so what's the integral of e to the u? It's e to the u. Keep the 1/5 in the front, right? Don't forget your plus c. And then we're going to replace u with what it was originally, 5x minus 3. Bueno?
Really?
Yeah.
And we are going to put plus c this time.
That's right. The only time you don't is when you have a definite integral. So which one of these up here, Graydon, will we not put plus c?
Oh, good.
Okay, you got it. Good. Yeah.
Where did the 5 go?
Oh, so I had du over 5, right? And anytime you have a constant that you don't want there, you could factor it out. So I put it over here as a 1/5. Yeah. All right, so let's go ahead and write down number 2, please. Write down number 2. And just so you guys know while you're writing down number 2, I don't record my review sessions. I'm going to pause this real quick. I don't record but we'll see. Let's go ahead and do number 2 here. So what's my u going to be? No, actually it won't. It's the exponent. So usually, like I said, when you're dealing with e functions, it's usually the exponent. So what is the derivative of that? 2x plus 1. Okay, so let's rewrite this a little bit. I've got a 2x plus 1, right? I've got an e to the u and a du over, I should say 2x, not dx. 2x plus 1, bless you. And then these guys go away, right? Pretty nice. Now, but we're not done. What else do I have to do before I'm done with my u substitution?
Change the limit.
Very good. You got to change those limits. It's not going to be 1 and 0 anymore, right? So we have to plug in 1, which would be 2, right? And then we're also going to plug in 0, which I think we already know is going to be 0. So it's instead of going from 0 to 1, it's going to go from 0 to 2 now. Okay? So now I've got the integral from 0 to 2 of e to the u du. The integral of e to the u is e to the u. no c, right? When you're doing definite integrals. So that means we have e squared minus e0, and e0 is ez. All right, what's e to the 0? Yeah. And we're just going to leave it like that. Let's do, I don't know. What time is it? What time do we get out of here? All right. Let's continue here. I think I'll do one more, and then I'll let you guys practice, and then we'll do number 4 as our last example. Go ahead and write down number 3. So, like I told you guys, usually when you're doing E problems, the exponent's going to be the U. But I hope you guys see that would be kind of a problem here. The exponent here is an x, and the derivative of x is 1. And you know how usually when you take the derivative, that thing goes in the bottom and it cancels something out? Well, 1's not going to cancel anything out, so that's not helpful. Okay, so the real way you can tell what u is, even though I'm giving you guys shortcuts like with e, it's usually the exponent. The real way you can tell if something is a u or not is if you see that u's derivative somewhere. So for instance, what's the derivative of x squared plus x? It's right there. So that, ding, 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 you've got a u. Okay? In this case, the derivative of x is just 1, and I mean there's a 1 there, but I don't know. Hope that doesn't ring any bells for you, because that's not quite right. What do you guys think is the u this time? Not sure? Okay, let's think back to when we very first learned u substitution. What was usually the u? The thing that was in the parentheses. In this case, it's the thing in the parentheses. Because check this out. If you take the derivative of that, what is it? Okay, so sometimes u substitution can be tricky like that. Most of the time it's not, but just giving you guys some heads up. So in this case, I'm going to say that my u is e to the x plus 1. And that means my du dx is e to the x, which means that dx is du over ex. So let's write it out. We have e to the x, u squared, du over ex, and the ex's go away. So now we have this. How do you integrate that? This is a gear changer here. It's a little bit different. You've got to remember old stuff. Just add 1 to the exponent and divide by the number. It's a power rule, because that's a power function. So we add 1 to the power and divide by that number plus c, right? And my u was e to the x plus 1. Okay, so number 1 is what I would call a basic example. Number 2 was remembering how to do definite integrals. Number 3 was a funky u sub example that turned into a different kind of integral altogether. Yeah.
So the squared next to the u is go away.
Well, when you integrate a power function, there's my square, right?
Oh, no, that's in the one parentheses.
This one here, right? So that's my u, right? So I replace this with u, and I get this. And so that's why I was pointing at this one. All right. So I'm going to let you guys practice before I do number 4, because number 4, I want to give it a little bit more special attention. The other stuff is really just kind of review and strange details. So, number 1 is a basic example. Number 2, I would call number 2 just another basic example, honestly. There's nothing special about it. It's not a definite integral. Number 3, yeah. This one, your trick is to find out your u, but it's actually not that bad. So, see what you guys can do there. I'll give you a few seconds. They're all pretty much the same, honestly. It's just that number 3 looks a little ugly. Huh? Oh. Shh. Don't say it. Okay, don't judge me. Okay, so here we go. We have yeah, that's your calculus teacher. That's who you're trusting your fate to. All right. Vivian, what did you get for number 1? Cool. You can have parentheses, not wrong. I'm not gonna put them, but you're right, that would be fine. So does anybody need to see number 1? Number 1?
Oh, no.
Okay. Neha, what did you get for number 2? Does anybody need to see number 2? Okay. So now we get to the weird ones. I think I'll work these ones out because I'm pretty sure people have questions about these. Let's go ahead and take a look at this. So we said on this problem here that our u was going to be 1 over x, right? And over there on the board, I worked it out already. We got that. But you know what? I don't know. We could do this. But I was talking to Thea, and she left it like this. That's interesting. I think I'll show you guys what she did. Because I like it. It's simpler. Okay, so there's our derivative, right? Because this can be rewritten as x to the negative 1. You multiply your negative 1 to the front, you take 1 away from there, right? And then we're going to get the dx by itself. Okay, then we come back over here to this thing. Huh? Yeah. Yeah. Yeah, because we're just swapping them, right? So actually, if you wanted to make it positive, that would bring it to the top. But anyway, so we have e to the u, and we have x squared, right? And then we have du over negative x to the negative 2. Now, let's bring this to the top. This is, oops. If I bring that to the top, what's it become? X to the negative 2, right? And you see how those cancel now? But that negative's left. So we have negative e to the u du, which means that it's going to come out to be negative e to the u plus c, which means if we replace the u, we get negative e to the 1 over x plus c. So the way I do it usually is different from Thea. I like what she did, though. She just kind of, what she did was, and actually I didn't do it fully her way. She started by just rewriting everything like this. I think that's way easier actually, and maybe I would encourage you guys to do that in the future. So she just changed this to an x to the negative 1. She changed this x squared to x to the negative 2. And it's just, I don't know, it's a lot clearer, I feel. I've been leaving them as fractions, and nobody likes fractions. So I like that strategy. All right. Let's go ahead and take a look at our last one there. So what's our u on number 4? Cosine, right? And what's the derivative of cosine? Negative sine, right? Okay, so we have integral sine x e u du over negative sine x. The sine x's go away. And I'm also going to take that negative out and throw it to the front. Okay? But we're not quite done yet because we also need to find our limits, right? So we need to come back up here to this, and we need to plug in two things. We're going to plug in pi. What's that going to be? Negative 1. And then we're also going to plug in 0. What's that? That's 1. So let me write it prettier now. We have a 1 on the bottom and a negative 1 on the top, a negative out here, and it's e to the u du. Now I don't know if this looks weird to you guys because we're supposed to usually have the bigger number on top, right? Smaller number on the bottom. But when you do u substitution, this can happen, and we're going to leave it like that. Okay. All right. So we know the integral of e to the u is e to the u, right? Bring down your negative, get rid of the integral, put brackets instead. 1 and negative 1. Right? So we have negative e to the negative 1 minus negative e to the positive 1. Now, I wouldn't be surprised if they wanted you to combine those, although here's one possible answer we could have. They might just leave it like this. Double negatives would be written as a positive. They might just leave it like that. That's possible. But it's also possible that they would do this because they had a negative exponent, right? And in that case, it's also possible that they might want you to get a common denominator and combine them. What would I multiply the bottom by? And so I'm going to be left with negative 1 over e plus e squared over e. And that, I'm going to rearrange the top. I'm going to put the e squared first, the negative 1 second. So it's possible they'll combine them. We don't know. So any of these answers here are probably fair game. I wanted to do one more example with you guys before we left today. We only got 3 minutes. We got, no, 9:36, right? Yeah. Okay, we got 9 minutes. That's good. All right. Can I erase? Write down number 4, please. Sometimes you're going to write them as two separate fractions. So here's what I mean by that. We have 5 minus, I'm going to rewrite it. You can put the 5 over e to the 2x minus e to the x over e to the 2x. You see what I did there? I split that one fraction up into 2. That makes integration a lot easier sometimes. So now in the first case, what I would say we want to do is we want to change this to e to the power of what instead? Yeah, because we want to move it to the top, right? But as for this second one over here, we can simplify this a little bit. What's e to the x over e to the 2x? Anybody know? Huh? Yeah, it's like this one takes away one of those, and you're left with 1 over e to the x, right? And how am I going to rewrite that? Negative, right? So we're going to call that e to the negative x. That's going to be a lot easier to integrate. Now, what we're going to do is we're going to take this integral and we're going to do each piece separately. And that's it. That's the big aha there. The rest of it's pretty straightforward. So, sometimes you can split it up. I rewrote them. And after that, it becomes easier. You guys want to take it home and finish that problem for me?
Yes, Mr. Bailey.
Good. I like that enthusiasm. All right. Why don't you guys go ahead and do it? I'll give you guys a little bit and I'll